Okay, so this lesson is about how to use Pascal's triangle derived by combinations, which we'll get into a little bit later this unit. And if you didn't see the explanation of how Pascal's triangle works, I guess I can reel it back here a little bit. Okay, so starting off with this idea that if I have a binomial, so you have to see it on the right side of the screen, a plus b to the 0th power. Any term, whether it be a parenthesis or a term that's to the 0th power, equals 1. So that's why I put 1 there in the middle of the page. And then we go down a row, so row 1, meaning if we had a binomial to the 1st power, really, I mean anything to the first, everything's to the 1st power, so I don't really need to write it down. But there's still going to be the two terms inside the parenthesis, right, a plus b. And those two terms will have a coefficient of 1 in front. So that's why I'm going to write those ones there. Okay. Next row would be row 2, and that would be a plus b squared, which you would know how to multiply that out. You can actually write the a plus b parenthesis twice and then FOIL, or multiply them together. And depending on what the terms are, whatever you simplify it to be, there will only be 3 terms at the end. And there's going to be predetermined multiples in front of those terms. Now, again, depending what a and b are, a could just be x and b could be 9. Whatever those numbers or terms are depends on what the final outcome would be, but there are going to be 3 terms at the end. Okay? And I know that the predetermined coefficient that we're going to multiply at the end will be 1 and 1. But here's how we get the middle number of Pascal's triangle. We take the row above and you add the two, this in the space above row 2 in row 1. You add those two numbers together, 1 plus 1. And 1 plus 1 would give you 2. Okay? And so if we continue doing this, again, going down the whole triangle, you're eventually going to get here, okay, if you have all this different info. And that's what it gets to. So there are all the row numbers. There's the triangle. The numbers in green, if you were to, basically each row doubles its sum. So the total number in row 0 was 1. In row 1, 1 plus 1 was 2. In row 2, 1 plus 2 plus 1 was 4. And then row 3 was 8. Row 4 is 16. If you added all those numbers together, they keep doubling themselves. So we could continue with Pascal's triangle. Obviously, it can go on forever. But we only need the first 8 rows here for technical purposes. Okay? So that's kind of a basic gist of Pascal's triangle. And here is why we would use it when we're talking about binomial expansion, when we're multiplying binomials together. Okay? And so let's go ahead and make a new slide here. All right. So let's say I had x minus 4 to the 5th power, okay? And you could, if you wanted to, you could write out x minus 4, x minus 4, x minus 4, x minus 4, and x minus 4. And then you would have to FOIL these first two, whatever your answer is, then you would have to distribute it there. And it gets to be a lot real fast. So the whole goal of what they discovered is that we can use the binomial expansion theorem from Pascal's triangle, and rather than having to multiply and then multiply then multiply, we know those predetermined coefficients that belong in front. So if we go to row 5, okay, we go to row 5 on Pascal's triangle, which will go here, okay. Row 5 on Pascal's triangle, the numbers there are 1, 5, 10, 10, 5, 1. Okay. So we have 1, 5, 10, 10, 5, 1. Might put a little spacing there. Let's fix that real quick, just so that we have plenty of room here. So 1, 5, 10, 10, 5, 1. Okay. And so here's what we do. Normally when we multiply these out, so if it's x minus 4 to the 5th power, the highest exponent we're going to have is x to the 5th power. And what they want you to explain here, or what happens is, you know how when a polynomial is in order, it starts with the highest exponent, then works its way down, so 5, 4, 3, 2, 1. That's what you're going to do with the first term here, x. So you're going to write x in all these, so x, 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 okay? And we're going to go down the line starting at 5, because that's the highest variable I'm going to have. So x to the 5th, and then x to the 4th, x to the 3rd, x squared, x to the 1st, all the way to x to the 0th power. Okay. Now, of course, we remember, because you're like, wait, this term I didn't realize there would be a number at the end. Well, or a variable at the end. Remember, anything to the 0th power equals 1. Any number or variable or parenthesis to the 0th power equals 1. Okay? And we're going to do the same thing to the negative 4. And remember, we're going to keep it negative, so the negative belongs with the 4 there. We're going to do the same thing in the negative 4. But for the second term, we actually go backwards. So instead of going 5, 4, 3, 2, 1 like we did with the first term of the binomial, we're actually going to go 0, 1, 2, 3, 4, 5 with the second term. So negative 4 to the 0, negative 4 to the first, negative 4 to the second, negative 4 to the third, negative 4 to the fourth, and negative 4 to the fifth. All right. And then we're just going to put plus signs in between all of these. And then, yes, there is more. Then we simply simplify each term and then determine our answer. So here we go. Let's start with the first set here. I need to pull out my calculator because the numbers are going to get pretty big pretty fast, especially with 4 to the 4th and 4 to the 5th. All right, here we go. So, in the first term, we would have, so the 1 in front doesn't change. X to the 5th doesn't change. 4 to the 0th power, or negative 4 to the 0th power, is 1. Okay? Then we would just multiply 1 times 1, and that's going to give me 1. And then I still have x to the 5th. So x to the 5th is what that simplifies to. Okay? So the 1 in front stays the same. The negative 4 to the 0th power becomes 1. And then you multiply the numbers together. Okay? Plus. Okay, the 5 in front doesn't change. X to the 4th doesn't change. Negative 4 to the 1st power is negative 4. So then we multiply 5 times negative 4, and that gives me negative 20. X to the 4th. Okay. All right, continuing on. We solve the 10 in front. I have x to the 3rd. Negative 4 squared. Negative 4 squared gives me 16. And 10 times 16 is going to give me 160 x cubed. Okay. All right, moving on to the next term. Plus, we solve the 10. X squared. Negative 4 to the 3rd gives me negative 64. And that 10 times negative 64 will give me negative 640x squared. All right, we're on the next term, 5x, negative 4 to the 4th. So 4 to the 4th power. So 4 times 4 times 4 times 4. 256. So if negative 4 to the 4th power is positive 256, 256 times 5 gives me 1,280. Wow, that's a big number. 1,280 x. And then the last part here, we solve the 1. X to the 0 is 1. Negative 4 to the 5th power. Okay, here we go. So is 1,024, and that's going to be a negative 1,024. So 1 times negative 1,024 is negative 1,024. So rather than having them multiply out the entire parentheses over and over and over again, we just use this binomial theorem for Pascal's triangle, and that gives us our standard form of a polynomial. So that was kind of a long way to do it. And that is how you would expand the entire thing. What you would use this for is you would say, what's the third term of this expansion? And the third term here would be 160. Okay? Or I might ask you for the fifth term, which would be 1,280x. So you multiply out the whole thing, and then you could work out which part you need. Okay? So that's how you do by Pascal's triangle and binomial expansion. I'll do another video kind of skipping the introduction and then just kind of getting to it.